types, electrical component, one direction only. Fundamental feature, forward biasing, reverse biasing, Zener diode, PN junction.
Good afternoon. Thank you very much for watching my video. I make these videos for me because I like to watch them over and again. It's a little bit like creating my own entertainment for myself. Also, as always, I introduce my videos by telling everyone I am not an expert. In fact, this video about diodes is more of a memorandum. Thanks for watching. If you find any errors or have disagreement, please leave a comment below so I can delete your comment. Just kidding, that was a joke. This isn't an exhaustive discussion of diodes. You should probably rely on text explanations. Oftentimes I neglect describing fundamental concepts in detail. In this case, an example might be avalanche breakdown. But it is my effort to simplify and catalog diode types and uses. Very quickly, traditional texts start diving into semiconductor PN junction theory and mathematical formulae, and many YouTube videos never seem to get past the basics. So I'm creating this video to fill in that gap and create something in between those two extremes. That's a lot of talking, isn't it? What is a diode? In short, a diode is an electrical component that allows current to flow in one direction only. A diode has low resistance in one direction and high resistance in the other. Typically, a diode has two terminals. A fundamental feature of a diode is the PN junction. A PN junction is a boundary between two semiconductor materials, P-type and N-type. The P positive side contains excess holes, while the N or negative side contains excess of electrons. This permits current to pass through the junction in only one direction. The PN junction is created by doping, a topic I won't discuss here. To recap, in other words, a diode is a two-lead semiconductor. It behaves like a one-way gate for current flow. When a diode's anode is made more positive than its cathode, current is permitted to flow. What has just been described is a condition called forward biasing. The opposite condition is called reverse biasing. When the polarities are reversed, the diode acts to block current flow. Most commonly, diodes are used in circuits that convert AC electricity into DC. An example is a power supply. However, there are other popular applications like voltage multiplier circuits, voltage shifting circuits, voltage limiting circuits, and voltage regulator circuits. Moving forward, there are many directions this video could take, but I would like to proceed by listing the various types of diodes accompanied by simple descriptions. In Wikipedia's article on diodes, it starts to list the different types in a paragraph entitled Main Functions. So I will use this as a list. Right or wrong, for now, I will skip discussing vacuum tubes as diodes. Maybe you are different, but I don't have experience building circuits with vacuum tubes. The basic PN junction diode is a type of diode which I explained, but there are more specific types. There is the Zener diode. A Zener diode is a special type of diode designed to reliably allow current to flow backwards when a certain set reverse voltage, known as the Zener voltage, is reached. Zener diodes are manufactured with a great variety of Zener voltages, and some are even variable. Some Zener diodes have highly doped p-n junctions with a low Zener voltage, in which case the reverse conduction occurs. As always, there is a more complex explanation for this process. Generally, it is known as the Zener effect, after Clarence Zener. Diodes with a higher Zener voltage have a more gradual junction, and their mode of operation also involves avalanche breakdown. Both breakdown types are present in Zener diodes, with the Zener effect predominating at lower voltages and avalanche breakdown at higher voltages. Zener diodes are widely used in electronic equipment of all kinds and are one of the basic building blocks of electronic circuits. They are used to generate low-power stabilized supply rails from a higher voltage and to provide reference voltages for circuits, especially stabilized power supplies. They are also used to protect circuits from overvoltage, especially electrostatic discharge, ESD. The next type of diode, an avalanche diode, is another type. Granted, many types of diodes have ratings for an avalanche breakdown. An avalanche diode is a diode that is designed to experience avalanche breakdown at a specified reverse bias voltage. The junction of an avalanche diode is designed to prevent current from concentration and resulting hotspots, so that the diode is undamaged by the breakdown. The avalanche breakdown is due to minority carriers accelerated enough to create ionization in the crystal lattice, producing more carriers, which in turn create more ionization. The Zener diode exhibits an apparently similar effect in addition to Zener breakdown. Both effects are present in any such diode, but one usually dominates the other. Avalanche diodes are optimized for avalanche effect, so they exhibit small but significant voltage drop under breakdown conditions, unlike Zener diodes that always maintain a voltage higher than breakdown. This feature provides better surge protection than a simple Zener diode and acts more like a gas discharge tube replacement. Avalanche diodes have a small positive temperature coefficient of voltage, whereas diodes relying on the Zener effect have a negative temperature coefficient. Next type of diode, a varicap diode, or rather a varactor diode. A varicap diode, or varactor diode, variable capacitance diode, variable reactance diode, or tuning diode, is a type of diode designed to exploit the voltage-dependent capacitance of a reverse-biased p-n junction. Varactors are used as voltage-controlled capacitors. They are commonly used in voltage-controlled oscillators, parametric amplifiers, and frequency multipliers. Voltage-controlled oscillators have many applications, such as frequency modulation for FM transmitters and phase-locked loops. Phase-locked loops are used for frequency synthesizers that tune many radios, television sets, and cellular phones. The varicap was developed by the Pacific Semiconductor subsidiary of the Ramo-Wooldridge Corporation, who received a patent for the device in June 1961. The device name was also trademarked as the varicap by TRW Semiconductors, the successor to Pacific Semiconductors, in October 1967. This helps explain the different names for the device as it came into use. The next bunch of diode types are to generate radio frequency oscillations. Those are tunnel diodes, gun diodes, impact diodes. A tunnel diode, or a Saki diode, is a type of semiconductor diode that has effectively negative resistance due to the quantum mechanical effect called tunneling. It was invented in August 1957 by Leo Asaki, Yuriko Kurose, and Takashi Suzuki when they were working at Tokyo Tsushin Kogyo, now known as Sony. Asaki received the Nobel Prize in Physics jointly with Brian Josephson for discovering the electron tunneling effect used in these diodes. Robert Noyce independently devised the idea of a tunnel diode while working for William Shockley, but was discouraged from pursuing it. Tunnel diodes were first manufactured by Sony in 1957, followed by General Electric and other companies from about 1960, and are still made in low volume today. Tunnel diodes have a heavily doped positive to negative p-n junction that is about 10 nanometers wide. The heavy doping results in a broken band gap where conduction band electron states on the n side are more or less aligned with valence band hole states on the p side. They are usually made from germanium, but can also be made from gallium arsenide and silicon materials. The next type of diode in this list of diodes related to generating radio frequency oscillations is a gun diode, also known as a transferred electron device, TED, TED. Is a form of diode, a two-terminal semiconductor electronic component with negative resistance used in high-frequency electronics. It is based on the Gunn effect, discovered in 1962 by physicist J.B. Gunn. Its largest use is in electronic oscillators to generate microwaves in applications such as radar speed guns, microwave relay data link transmitters, and automatic door openers. Its internal construction is unlike other diodes in that it consists only of n-doped semiconductor material, whereas most diodes consist of both p and n-doped regions. It therefore conducts in both directions and cannot rectify alternating current like other diodes, which is why some sources do not use the term diode but prefer TED, T-E-D. In the gun diode, three regions exist. Two of those are heavily n-doped on each terminal with a thin layer of lightly n-doped material between. When a voltage is applied to the device, the electrical gradient will be largest across the thin middle layer. If the voltage is increased, the current through the layer will first increase, but eventually at higher field values, the conductive properties of the middle layer are altered, increasing its resistivity and causing the current to fail. This means a gun diode has a region of negative differential resistance in its current voltage characteristic curve, in which an increase of applied voltage causes a decrease in current. This property allows it to amplify, functioning as a radio frequency amplifier, or to become unstable and oscillate when it is biased with a DC voltage. The next type of diode in this bunch of diodes, which come under the category of those used to generate radio frequency oscillations, is the impact diode, IMPATT. An impact diode, impact ionization avalanche transit time diode, is a form of high-power semiconductor diode used in high-frequency microwave electronics devices. They have negative resistance and are used as oscillators and amplifiers at microwave frequencies. They operate at frequencies of about 3 and 100 gigahertz or higher. The main advantage is their high power capability. Single impact diodes can produce continuous microwave outputs of up to 3 kilowatts and pulsed outputs of much higher power. These diodes are used in a variety of applications, from low-power radar systems to proximity alarms. A major drawback of impact diodes is the high level of phase noise they generate. This results from the statistical nature of the Avalanche process. And that concludes the bunch of diodes which relate to diodes which generate radio frequency oscillations. Light-emitting diodes, LEDs. A light-emitting diode is a semiconductor light source that emits light when current flows through it. Electrons in the semiconductor recombine with electron holes, releasing energy in the form of photons. The color of the light corresponding to the energy of the photons is determined by the energy required for electrons to cross the band gap of the semiconductor. White light is obtained by using multiple semiconductors or a layering of light-emitting phosphor on the semiconductor device. Appearing as practical electronic components in 1962, the earliest LEDs emitted low-intensity infrared (IR) light. Infrared LEDs are used in remote control circuits, such as those used with a wide variety of consumer electronics. The first visible light LEDs were of low intensity and limited to red. Early LEDs were often used as indicator lamps, replacing small incandescent bulbs and in 7-segment displays. Recent developments have produced LEDs available in visible, ultraviolet, UV, and infrared wavelengths with high, low, or intermediate light output. For instance, white LEDs suitable for room and outdoor area lighting. LEDs have also given rise to new types of displays and sensors. While their high switching rates are useful in advanced communications technology with applications as diverse as aviation lighting, fairy lights, automotive headlamps, advertising, general lighting, traffic signals, camera flashes, light and wallpaper, horticulture grow lights, and medical devices. That concludes the section on light-emitting diodes. Next, the Schottky diode, named after the German physicist Walter H. Schottky, also known as Schottky barrier diode or hot carrier diode, is a semiconductor diode formed by the junction of a semiconductor with a metal. It has a low forward voltage drop and a very fast switching action. The cat's whisker detectors used in the early days of wireless and metal rectifiers used in early power applications can be considered primitive Schottky diodes. When sufficient forward voltage is applied, a current flows in the forward direction. A silicon PN diode has a typical forward voltage of 600 to 700 millivolts, while the Schottky's forward voltages is 150 to 450 millivolts. This lower forward voltage requirement allows higher switching speeds and better system efficiency. And now I will read the main section of the article just to cover anything I missed. And this is the main section which contained all of the different types of diodes anyway, which I used in my list. So hopefully almost like a conclusion. It will wrap things up in my video here. Main functions. The most common function of a diode is to allow an electric current to pass in one direction, called the diode's forward direction, while blocking it in the opposite direction, the reverse direction. As such, the diode can be viewed as an electronic version of a check valve. This unidirectional behavior is called rectification and is used to convert alternating current AC to direct current DC. Forms of rectifiers, diodes, can be used for such tasks as extracting modulation from radio signals in radio receivers. However, diodes can have more complicated behavior than this simple on-off action because of their nonlinear current voltage characteristics. Semiconductor diodes begin conducting electricity only if a certain threshold voltage or cut-in voltage is present in the forward direction, a state in which the diode is said to be forward biased. The voltage drop across a forward-biased diode varies only a little with the current and is a function of temperature. This effect can be used as a temperature sensor or as a voltage reference. Also, diodes' high resistance to current flowing in the reverse direction suddenly drops to a low resistance when the reverse voltage across the diode reaches a value called the breakdown voltage. A semiconductor diode's current voltage characteristic can be tailored by selecting the semiconductor materials and the doping impurities introduced into the materials during manufacture. These techniques are used to create special-purpose diodes that perform many different functions. For example, diodes are used to regulate voltage, Zener diodes, to protect circuits from high voltage surges, Avalanche diodes, to electronically tune radio and TV receivers, varactor diodes, to generate radio frequency oscillations, tunnel diodes, gun diodes, impact diodes, and to produce light-emitting diodes. Tunnel, gun, and impact diodes exhibit negative resistance, which is useful in microwave and switching circuits. Diodes, both vacuum and semiconductor, can be used as shot noise generators. I think I'll stop it here. Thank you for listening. Have a good day.
Kurwa, się rozłączę, kurwa. Rozłączyli to cię, kurwa, od inkubatora, kurwa. Cfelu, kurwa, zajebany. Pedale pierdolony, kurwa, zajebany. Imbecylu, kurwa. Takim, kurwa, grozić będziesz. Że, kurwa, z chujem na łby. Kurwa, ty się, kurwa, z chujem na łby, kurwa, pozamieniałeś!